completing its 75 years of independence in 2022. And in the same year, CSIR, which was established in the pre-independence era, will be completing its glorious 80 years of service to the nation. These weekly activities that we are taking up in the form of webinars, posters, and blogs are basically to mark the Azadi Ka Amrit Mahotsav initiative and also to showcase the 80 years, 80 success stories of CSIR. Today's webinar is 11th in the series and is organized to share success story from one of our research laboratory, which is internationally known for its excellence in scientific research in the fields of chemistry and chemical engineering. The very well-known National Chemical Laboratory, CSIR-NCL, situated in Pune. And the topic of the talk today is one of the recent success story of CSIR-NCL, the dimethyl ether process technology, or we call it as DME process technology, an ultra-clean fuel. So among the dignitaries, we have with us today Director CSIR-NCL, Dr. Ashish Lele, Director Technical Engineers India Limited, Ms. Vartika Shukla, Deputy Director, Automotive Research Association of India, Dr. S.S. Thipse, and Dr. T. Raja, Principal Scientist from CSIR-NCL. I am Dr. Shikha with you, Scientist from the Science Communication Directorate at CSIR Headquarters, your moderator today, and I welcome you all for the talk and discussion on CSIR's DME process technology. So with this, I now request Director NCL, Dr. Ashish Lele, to kindly deliver the opening remarks for the session and also welcome our esteemed participants and the enthusiastic audience who have joined with us for exchanging knowledge on the technology. So over to you, Dr. Lele.
Thank you, Dr. Shikha. Thank you so much. This is a wonderful series that CSIR has created. It marks the 75th Independence Day and the 80 glorious years of CSIR. So it's an exciting opportunity, and we are very delighted as part of the CSIR and particularly NCL family to present one of our recent success stories. So we are very delighted to have that. And any real success, which is translation of science to technology, doesn't happen without partners. So I am especially delighted to welcome and also thank both Dr. Thipse and Dr. Vartika Shukla for partnering with us and also finding their time out of their very busy schedules to come and participate in this seminar. DME is a very, very interesting molecule, and I'm not going to say too much about it because I'm going to ask my expert, Dr. Raja, who's really championed this whole technology development process, to talk about it. But just to put things in perspective, as climate change becomes an important scenario, there is a definite need to remove CO2 to first reduce CO2 content that we are emitting, but also the CO2 that has been emitted in the environment would be nice to pull it out. And one of the ways there are many technologies to capture CO2 from flue gases, from direct air, and so on. And the question is, what do we do with that CO2? So one of the technologies that is emerging and now finding great interest is to convert the CO2 into methanol. Right? So methanol becomes a very interesting fuel, but more importantly than methanol is dimethyl ether, which is the next value add to methanol. It's a very, very interesting molecule that has the potential to substitute LPG, particularly propane in the LPG, which all of us know, and also has the potential to even replace diesel as a fuel. So this would be completing a very interesting cycle, very interesting carbon cycle, where CO2 that is emitted into the atmosphere can actually be trapped and reused in the form of fuel. So I think this is a very contemporary, very, very important molecule, and we are very happy that CSIR NCL has taken the lead in developing technology for this. Raja will talk more about it, how DME is produced from methanol. And what NCL has done, which is a wonderful catalyst that we have developed, a very nice reactor configuration that we have developed, some burners which can be used to burn dimethyl ether directly. And all of these are protected technologies with filed IP around it. These are globally benchmarked technologies where the catalyst has been compared with the best in the world and shown that we can actually do better than the best in the world. So these are all very exciting. Not just the science is exciting, but its translation into technologies is very exciting. And as I said, the translation part is perhaps even more important, and it is very difficult for a single laboratory to do this. So with the great help from EIL, which is a premier engineering institute that helps to transfer, to scale up and transfer technologies, commercialize it. It's great to see their partnership. And if DME really comes, and if it's not if, when it will definitely come to the market on a commercial scale, the application part of it is equally important. There are a lot of testing required for it, regulatory compliance is required for it, and a lab like ARAI comes in a big way to support that. Without their involvement in it, the commercialization will be only a half completed story. So it's very nice to see three major institutions playing a very big role in a topic that is very, very contemporary. So I'm sure the audience here would be interested to understand more details about it. And without further ado, I'm going to leave the details to my colleague, Dr. Raja, who, as I said, is a very renowned scientist in NCL and has taken great leadership in this very, very important program. So should I let Raja take over? Shikha, you can moderate then.
Yes, sir, I will be moderating. So thank you so much for briefly informing our viewers about the technology and its importance as an alternative fuel. So before we go further, I would like to inform our viewers that this session is getting live telecast on CSIR India Facebook, YouTube, and Twitter web pages. And the interested audience can post their queries, which is relevant to the today's talk, in the chat box of the social media pages. And we shall be taking those questions at the end of the session during the discussion with the speakers. So let us move forward and let us go with our first speaker for the webinar, Dr. T. Raja, who is Principal Scientist in the Catalysis and Inorganic Chemistry Division at CSIR NCL. Dr. Raja obtained his PhD from University of Madras and has been JSPS Fellow and CRNS Fellow for his postdoctoral studies. He has several prestigious awards in his name, such as CSIR Technology Award of 2015, NCL Research Foundation Award on Technology Development, Commercialization and Process Development, and also the NCL RF Award on Technology Development. So with this brief introduction, may I now invite Dr. T. Raja for his talk in today's session, describing us more about the DME process technology. So over to you, Dr. Raja.
Yeah, thank you, Dr. Shikha. Yes, I'll share it.
Yeah, please share the slides.
Is it visible?
It's visible, sir.
Yeah. Thank you for a nice introduction. And once again, I welcome to all the audiences who is interested on our success DME success story, and then CSIR the 80 years of the glorious years of here for the people of our country. So just I'll talk with Dimethyl ether, how it will evolve, how it comes, and everything. The things which since the time is limited, just I will restrict my talk less technique. And this is the Ambitious project, CSIR Ambitious project to reach people of India through science. CSIR developed under the Mission Mode project and identified DME production under the catalysis for sustainable development, which will lead to a significant reduction in nation's LPG and crude forex bill and bolster the Atmanirbhar Bharat initiative. Under the scheme, there are 3 or 4 projects and an all chain of laboratories, around 9 laboratories we have, and then 3 laboratories we are working on DME with syngas to methanol, methanol to DME, or syngas to DME, and then methanol degradation DME. So NCL is the nodal lab, and then we are taking care of all the DME and all the projects. So under this scheme, and then CSIR NCL developed an innovative, sustainable, and most effective DME process with the help of our protected indigenous catalyst systems and reactor design. We have developed indigenous catalyst systems, 2 systems, and the reactor design. This catalyst is this reaction process is exothermic reactions. So we have to remove the heat as well as the product water also. So we have indigenously developed the reactor design also. And then under the scheme, under this Mission Mode project, we developed around 7 patents, out of which 5 I have given here. 2 are catalysts and 1 is the reactor design. The another one is the DME used as a chemical commodity. And another one is whatever we are the end product, we are getting DME as a fuel. So we need to have a design and burner. And then we are also looking for a industrial burner also. So all with our team and everything. And then Niti Aayog also already very interested and already identified our DME process technology as a strategic research work and essential for our nation, and advised us to take it to further industry scale 1.5 to 10 million metric ton per day. So much collaboration we have done and everything. Then now we are having us going to have some small plant at here. And then out of this one, FTO, the freedom to operate and freedom to practice analysis has done by the CSR. The report is very positive for our methanol degradation DME process. So far, we have done the laboratory scale 1 gram to even 5 kilogram catalyst synthesized with appropriate binder with proper strength to reach the industry. From the beginning, we have taken care for the catalyst should be very strength, and then it should not crumbling enough and everything. So we have taken that appropriate binder, suitable binder with shape and size. And then CSR also completed the basics. Our group completed the basic scale-up studies, and required plant site is finalized for 0.5 ton TPD demonstration plant at CSR NCL. It has to be very careful to carefully we have done with the land acquirement and everything for the industry perspective. What is the properties of DME? As Dr. Ashish Vile told, DME is one of the most promising second generation alternative fuel, and globally it's considered as ultra clean, green, and low carbon emitting fuels. So we are closely working with ARAI also. And then DME can be used as a fuel in diesel engines and gas turbines without any modification. This also possibility is there. So both we are doing things simultaneously with ARAI. And the giants, the Nissan and Volvo developed heavy vehicles running on diesel engines and past years. So LCV as well as high commercial vehicle also possible with the DME as a fuel. And as an alternative fuel, it's when compared with the fossil fuels, DME performance demonstrated a number of significant benefits. One is less pollutants, that is like hydrocarbons, soot, and very particulate matter is very less, and less CO2, less nitrous oxide, and then no sulfur oxides than conventional fuels, which help to restrict the level of pollution across the country. When using DME as a fuel, the engine noise will be less and high fuel economy. Then ignition character is also equivalent to the diesel engine since its high cetane rating up to 55 to 60 when compared to the fossil fuel diesel. And then it has a low boiling point, minus 24.8, which provides a fast fuel air mixing and excellent cold start and reduced ignition delay in coal countries and everything. And it has very good properties like LPG, domestic LPG, where we are using easy to store, easy to transport, and then easy to carry over everywhere. So 10% carbon reduction is combustion balance is compared to the diesel. So again, we are awaiting the ARAI results and everything. Still it is there, and it has a very low global warming potential, 0.3 at the rate at 100 years. And these are the properties just we want to compare. As I said, it is equivalent to LPG. LPG is nothing but propane, whereas in our country, propane and butane and vapor pressure is almost equal. So it easily can substitute up to 20%. And then the cetane number also when comparing diesel, it is around almost equal. So it can be replaced for mostly an LCV, HCV. Even we are trying to have ships and everything for so many government schemes. And these are the LPG imports. A comparison. Just we were bypassing with the Asian regions, South Korea, Japan, China, and India when comparing. And monthly average we surpassed China's import of 2.3 million metric tons. So when comparing this one, the forex is very much high actually. The monthly average is very less, and even monthly average is more in December that monthly average is more than yearly average. So we need to very curtail this kind of the foreign exchange money to go for import for the import of the LPG. So just a CSR developed an ambitious project through mission mode to reach the people. One is the DME for substitute for LPG as well as diesel. So as I said, India is the world's largest LPG importer, and already India has imported around 2018-19 226 million metric tons of crude oil, and then from there come to LPG. And then the ambitious project of Prime Minister Ujjwala Yojana, a clean cooking fuel for below poverty line people to give energy justice, which drives the demand furthermore. So far we have 7.19 crore connections given, and it's likely to be more due to the COVID and the lockout reasons. Still, the system will be, I think, drives will be more actually. It's we're expecting. As I said, the government's push to provide a clean cooking fuel to every household has turned India into the world's second largest LPG consumer, whose demand is projected to rise 34% by 2025. The compounded annual growth rate is 15% when comparing 2014 to 17, the LPG consumers. The rapid increase in pollution combined with LPG penetration in rural areas has resulted in an average growth of 8.4% in LPG consumption, making India the largest consumer or importer of LPG in the globally. As per our Oil Ministry's projections and forecasts, LPG consumption is expected to grow 30.3 million tons by 2025 and 40.6 million tons by 2040. So the idea is demand is more. So we need to give a technology which is self-sufficient, self-reliance within India. So CSR developed 2017 or 18, it developed a mission mode project. Under this, we have developed this one. So the idea is here, already India has 191 LPG bottling plants operated by PSU, and then we our technology, even we can have a modular, easily mobile and everything modular in it. We can put it there, and even we can blend it with LPG with DME around 20% or whatever the regulations are allowed. So we can easily supply through 22,604 LPG distribution. And again, this import is more here. This is a graph of LPG consumption and crude gas production and imports in India. So the production is almost satisfied or a steady state, and then where exponentially the imports are more. So as we said, just we need to very care to take it. The foreign exchange should not go. And what are the achievements by doing so? By saying so, what we achieved during the process of DME on the project. So around the 2 methanol molecule will give you 2 moles of methanol, give 1 mole of DME and 1 mole of water, and then it will not go to lead to olefins, which is impurity for particularly for fuel. Whereas we patented even olefins also at the certain conditions. We know how to get olefins also on the same process. So under this project, around 50 catalysts synthesized and screened for activity and selectivity. The best we have selected. So the best optimized reaction conditions are 250 to 280 degrees Celsius at atmospheric pressure as well as pressure, 10 bar pressure for the best catalyst. And conversion achieved at 88 to 89% and 99% selectivity for DME is achieved with the atmospheric pressure. The scale of operation is 1 gram to 1 kilogram. It's a lab scale to a pilot industry scale. And then when it's a 10 bar high pressure, but because of post-processing unit, we need a high pressure, even 12 bar also. The conversion even achieved through our modified patented reactor. Conversion is achieved 99% and 99.5% purity or selectivity of DME, DME. And then the catalyst also synthesis up to 5 kilogram at lab level. And then the time on stream study, the continuous study has been given with most shocks and everything for the catalyst to check the durability and then water tolerance and so many parameters for industry needs at higher space velocity to get the more productivity. So the pilot plant scale, we achieved around 24 liters per day DME at 1 kilogram catalyst loading. And then at present, our technology level is around TRL 6 to 7, we can say. So how we were evolving, just a small video. This is a video in terms of the NCL, really, how we are getting the instruments. This was a meeting which at pilot plant we have developed to the university, and this is now the DME plant, and world-class facilities reactors installed for all users of the patented reactors, and this is an industry level getting at these different shapes, and this is a trial run with DME, and then first time in India rolling DME with all safety precautions in lab. Demonstration of the reactor, highest level of DME, and then we are demonstration with some other companies, and then another production of large DME production as well as conventional stove we are testing for copper, gas. Then we were preparing first time early morning 6 o'clock. We put the DME as a fuel for tea. So for this indigenous catalyst and how it evolved, how best our catalyst, just we have taken all our available commercial catalysts with comparing with our catalyst and our sister laboratory catalyst. Also, when you see that the space velocities different space velocities as well as different high temperatures, whereas NCL is giving an optimum temperature 260 to 270 at atmospheric pressure at a space velocity of 2 it means that if you are putting 1 kilogram catalyst, I can put 2 liters, so the productivity will be more. And then here is no co-feed with nitrogen or any inert gas we are not putting, whereas all over the world we are putting they are having an N2 as a co-feed. So here NCL is NCL catalyst is indigenous developed catalyst is showing better activity as compared to the available commercial catalyst. These are the the maximum evidence of durability of our indigenously developed catalyst. 3,500 hours continuously we run the catalyst with different reaction parameters, and here one of the parameters is the space velocity. See, we have the thermodynamic conversion is 88%, near 80. So WSP2 it is going on around 800-900 hours, and then we switch it to more supply of the methanol for degradation. So again it is coming down, and then we have pump stop, and then again we are increased the space velocity to the 4. Again we reduced. It is called kind of different shocks for the tolerance level of the catalyst. Again it's coming back and everything. Again WS3 is almost equal to the previous one. And when comparing with the regeneration of the in situ regeneration of our catalyst, we are gone back our production or conversion is as such the back. So again it's pump failure, again it's come down. So this is the catalyst which at 250 degrees Celsius, the conversion around is around 84 to 85% at the space velocity of 2, whereas when space velocity of 3 we switched over, it's reduced to 80 to 80%, and selectivity almost 98 to 99%, and then time on steam is around 3,500 hours. This is which is very important for any industrial or anyone who is coming for interested in our technology. And as I said, we are patented or IP protected for our catalyst as well as the reactor. So when a conventional reactor as well as the modified reactor here from our engineering team, so just be compared. So when in different conditions, we are almost modified catalyst, modified reactors improved our conversion and as well as yield of DME. So already the patent is granted and it's published already. But here we are practiced almost 1 kilogram catalyst loading level, and as well as 250 kilogram, that is different space velocities. And catalyst scaled up also 5 kilogram as well as now we are 10 kilogram scale up also we are achieved, and with the different shapes and exudate shapes as well as different kind of binders, and then we now metallize with the one, we carved out on one separate binder with a different percentage of binders, and then crush strength also we have developed to the vendor and ourselves. So it's a more crush strength available, so it will not crumble when it's loading, high loading, when higher scales. And these are the pilot scale patented reactors reactions. 24 liters per day we are, practice we are getting actually. So here also this one we are 575 hours, time on steam we have run this catalyst. As I said, this conventional reactions almost is around 85 to 88% is coming. When we are putting up in distillation coupled with the reactor to remove the one of the water molecule and then as well as the heat integration we are done, almost it is coming around 100% conversion as well as heat. The product will also improve, and then heat, the exothermic reaction heat is utilized properly for the plant. And these are the patent which we published recently around 6 months back. It's already published in our patented reactors. And these are the small video, again, one more time video. Dr. Harshvardhan, our Honorable Science and Technology Minister, Dr. Harshvardhan has come here and visited here personally, and before COVID, and along with the Dr. Harshvardhan, sorry, Dr. Professor Shekhar Mande, Honorable DGCSR, and then inaugurated this our plant, pilot plant. He has been felicitated by ex-director and coordinating person Tania. It is a DME plant which he inherited on September 9, 2019. Gopinath is chairman of Mission in 1960, and he inaugurated one of the plants. 9 years explaining. So my colleagues, divisional colleagues, and then this is my research team, comprising of engineers and scientists. And, after getting the DME and everything, we need to utilize. So we have some plans and how to utilize for fuel purpose to reach the people for domestic burners. So we have this is a PFD of a burner using a DME as a fuel. DME as separately we have developed a gas stove with the help of CFD. Energy efficient burner, and then you can use separately. You can use a DME as well as LPG DME blend also. So with this PFD, we developed Aditya Udaya shunt, a sets of burners which capable of DME as well as LPG alone. This is a certificate of registration of design, which is recently it come around a year back, or it come approved for the design actually from the government of India. And this is the first, central one is the first generation gas stove, which we can put it, supply of controlling air supply and everything. And then here the second generation with orientation and a lot of CFD work we have done with the orientation and how much opening, how much air fuel, which ratio and everything. And the third generation is the domestic fuel as such. It looks like a domestic burner, but inside is our technology incorporated. So first time we are operated and we boiling a milk, and we have demonstrated the Aditya Udaya sense inside NCL with different class of people with the technical and non-technical to reach different hands to get their inputs and feedbacks for a domestic purpose of DME as well as DME LPG blend. But first time we are using only directly DME as 100% DME as a fuel, which is using the burners. This is a semi-skilled worker, Vijayaraman, and then this is Dr. Mr. Jogdan, technical officer as well as safety officer in NCL. So their home and everything we practiced. We are examining that how it works and everything. He's a technical, and then he is an electrician in the electrical department along with Ms. Mani, who has helped us to a lot of things in the stove and fabrication and everything. And another one is this is a Yogesh Mahajan. Junior technical officer at home. We have put again tea and everything, and this is we demonstrated this stove, maybe around 500 to 600 teas we made it on the canteen cafeteria itself, and then Dr. Mr. Raut, who has mechanical section, who helped us to fabricate and then connections and everything, and these are the another beneficiaries. And this is again the small videos again we are getting. So blue flame is coming DME is those accumulates. These are the design of numbers. And bit of solution, we just generate how much calorific value, and then it reduced into the market for government the stoves. Different users we have given for different chapati and then rice, as well as dosa, different kind of people, number of family members, everything connected. Food claiming and getting this cafeteria, it's very thanks to that cafeteria, as well as this one, they allowed us to test our burner and everything. And these are the achievements of what we have done actually. So data collected for the performance of Aditya Urja Sanch, DME as a fuel or DME LPG blend as a fuel for the burner. And indigenously we have developed and designed, developed and then fabricated nation's first industrial DME fuel boiler unit. We have it to be demonstrated, and then the demonstration of nation's first DME fuel automotive engine with the help of ARAI. So next video is showing that it's the first one in our country. We have practiced how much DME as well as DME LPG blend, and then we have also DME LPG blend bottling unit, and then combustion trials for actual domestic use. And CSR also sanctioned a project under the fast track commercialization to have a demonstration plant of capacity of 0.5 tons per day for our technology, DME process technology, to various collaborators industries. And we are also supplied DME LPG2 blends to the Bureau of Indian Standards through IOCL. And then we have the future, what we have planned to have 100 liters per day DME, which is carried out of the whatever we prepared on 5 kilogram level. The reactor has come under modifications. Again, we have to start it. After that, due to the COVID reasons, we have hampered a lot of works here. Once it's everything, the restrictions removed, just we will do it on this one. And we are also have a nation's first 0.5 tons per day demonstration. It will be shaped further for industrial clients. We have also signed with the ARAI for testing DME fuels and various works, and then signage under the sister concern of debug nitrates. And then EAL, we signed MOU with them for using for erection and a large scale unit of DME for refineries and more industries. And then these are the small unit how we developed the DME as a fuel for a 3-year vehicle internal combustion engines, particularly for auto rickshaw. Just at the lab, it is small jar elaborate filling of DME. Our engineer has made actually, and for my office. While in the run, we have to stop. It is idling, yes, that is very good DME. It's little less noise for it. So it is quite DME. It's done by professionals. Really went well. And by doing so, what is the outcomes of our country, the nations? So this DME process technology is more helpful for the revival of methanol economy, which create employments, and it is offering an ultra clean fuel to bring down the level of air pollution across our country. In energy security of our nation, reduction in import bill, where we can forex saving, and where this is a very good, very much Niti Aayog interested for the strategic sectors and everything. And this technology will help to create employment opportunities in the country in various sectors, including the automobile industry. Various industries are interested in CSR or process technology. It covers Make in India, Innovate India, and Atmanirbhar Bharat. And it can be blended with LPG to fulfill the energy requirement of our nation under the scheme of Pradhan Mantri Ujjwala Yojana. It is tested and the ability to replace diesel, which is forecasted based on the experimental findings. DME can use a clean fuel instead of bunker fuel for the ships and the transportation, everything under the Sagarmala program. Even armed forces of our country is interested, so they are also looking for this kind of fuel. So already we had a talk with them, and this is a real fuel for sustainable mobility for our nation. And understanding the dimethyl is an alternative clean fuel which is used for the internal combustion engines without structural modification of the diesel engine, whether it's LCV, HCV, even in the ship, they very much appreciated. So now the ARAI is working on this one. And then these are our collaborators for Rashtriya Chemical Fertilizers, Assam Petrochemicals, and EIL, and then Deepak group of companies, J Chemicals, and Industry Development Services, who has given a white paper for our feasibility studies and everything. And through Deepak, we are in a college AHE and Process and Interface. We have a joint collaboration after some time. And Indian Glycol is interested not only DME, they are interested with Bio DEE also. Even MOU or NDA has signed with Indian Glycol also. And then Chirop Chemophobe interested on various ethers using our catalyst. And then ARAI is interested for testing as well as for regulatory attachments, approval and everything. And Kirloskar Oil Engines Limited is very much interested DME as a fuel for generators for various telephone or mobile phone application, mobile charging station applications and everything. So I need to thanks for the support. And these are our DME research team, whereas our team comprises of 3-4 people engineers: Vipul Pachil, Sivaprasad, Kiran, and then Mane, Samruti Mane, and then remaining all our chemists who developed the catalyst, and then the engineering team is developed the reactor and so many boiler units and everything. And I would like to thank, this is the last slide, I would like to thank for my collaborators EL or ARAI, RCF and Signation, and CSR India for funding as well as constant watch on us, interest on us, how this progress is going on, everything. Dr. Segar Mande is personally interesting, and then and there we are updating. And then we are very much thankful to Niti Ayog, Dr. Saraswat, member Niti Ayog, who has very much keen on to develop this technology indigenously in our country. So this is our NCL overview, or this photo. Our motto is first in reception reactor. The purpose of this laboratory is to achieve advanced knowledge and to apply chemical science for the good of the people. Soon we will reach the people. Thank you, one and all.
Thank you, Dr. Raja.
Yeah.
Thank you for describing our viewers about the DME process technology, its production, and the importance of its usage as an alternative household fuel, which will help in formation of a self-sufficient or self-reliance nation with reduction in import. And also the videos that you have showed on DME pilot plant at NCL and the fuel generated and its adoption in household activities. The commercial fuel for transport application, its application, and various other wide scopes of DME. It's really very fascinating to see the work and the efforts towards the development of DME in India. So thank you once again. So we'll move forward to our next speaker, who is Ms. Vartika Shukla, who is the Director Technical at Engineers India Limited. And Ms. Shukla graduated in Chemical Engineering from Indian Institute of Technology, Kanpur in 1988 and is certified with an Executive General Management Program from IIM Lucknow. She has over 32 years of extensive consulting experience comprising design, engineering, and implementation of complexes in refining, gas processing, petrochemicals, fertilizers, etc. She has also been recognized in the industry for her contributions in the oil and gas sector with several accolades, namely the first PetroFed Women Executive Award, the Scope Excellence Award, and the MOPNG Innovation Award, which was awarded with her team. So with this, may I now request Ms. Shukla to deliver her talk. Over to you, Ms. Vartika Shukla.
Thank you, Dr. Shikha. I hope I'm audible.
Yes, ma'am, you are audible.
Thank you. Thank you. First of all, my compliments to CSIR for arranging this exclusive webinar on DME, and also the presentation which is shared by Dr. Raja has been so enlightening. to see the remarkable progress which has been made on the catalyst front. So good afternoon, Dr. Ashish Lele, Director NCL, Dr. Tipse, ARI, and of course, Dr. Raja and his team for such an outstanding work. And a very good afternoon to all who have joined in to this webinar. Just to bridge some of the points which Dr. Raja has so very elaborately brought out in the presentation, the need for the hour and the Honorable Prime Minister's clarion call is towards self-sustaining our energy needs. India is growing. It's a large country with aspirations of people to have a clean, affordable, and sustainable energy source. DME fits into that bill to reduce the country's import bill. If we see the import that is happening in the petroleum products as well as the crude, it is more than 25% of our total import bill of around $480 billion. We are today more than 85% dependent on crude imports, and each and every energy source which can be domestically generated and produced is welcome to join the energy basket. So there is room for all sources of energy today in the nation. And therefore, the developmental cycle of conversion of methanol to DME kind of fits into one of that spokes in the wheel and the journey towards self-reliance. Statistics, if we see, as were also presented by Dr. Raja, the penetration of LPG has actually gone up from 55%, which we had in April 2014, to almost 97-98% by last year. There has been an aggressive and very policy-driven kind of push towards moving the population towards cleaner fuel, looking at the health of the women in the nation. The twofold use of DME, primarily as blended fuel to LPG, for which we already have BI specifications in place, as well as for blending in diesel as fuel, which I'm sure Dr. Tipse will mention, because there are projects to look at the the efficacy and the efficiency and other factors in diesel engine. These are all towards finding end use of something which we can produce domestically. World over, as we have seen, we have more than 10 million tons of DME production. And the point that I wish to make and share with the audience is that a lot of it is driven from coal as a feed source for syngas, which is converted to methanol and subsequent single step dehydration to DME. India, as you know, is poised towards valorizing its coal. There are many projects which are in the pipeline, whether it is conversion of coal through gasification to syngas to urea and ammonia and urea, or to look at a kind of a poly generation. And these are the technologies which are going to come into play in times to come, which are targeted towards clean coal, capturing the carbon of the coal to more valuable products. It may not be entirely green, as we are looking towards net zero moving forward. However, it will definitely reduce the dependence on LPG imports and overall imports of petroleum products. If we see today, the LPG imports are larger than what LPG volumes that we produce. Specifically, last year we imported about 15 million tons out of 27.5 million tons of LPG, which was the domestic consumption. So it makes good sense to look at blending this by at least bridging that time frame where we have a lot of gas penetration, which is likely to happen in the nation by way of PNG, going to every household. And this bridge, which is giving clean, reliable, and low emissions from the stoves and the applications which were shown to help us, meet our fuel demands. The journey in this, as EIL, is very cherished in terms of the association we have with NCL. And I do recall the meeting which was held under the chairmanship of member Niti Aayog, Dr. Saraswat, where he insisted that there is a more focused and a more attention-driven thrust towards looking at indigenously manufacturing both methanol and DME. And there have been several initiatives which are pushed towards R&D for conversion of syngas to methanol and thereafter methanol to DME. And in that very meeting in 2000s, around end of 2017, I had the opportunity to be there and initiate a dialogue with NCL, thereafter steered under the ex-director Professor Nangia and Dr. Gopinath and Dr. Raja. There was a concerted effort jointly to take the developments which have been shared just now towards commercialization. And why I bring this up is because it is the translation of the developments at the lab towards looking at these developments for process optimization, with particularly the catalyst uniqueness that we have with high conversions, such that the recycle costs are lower, the operating expenses are lower, and we have per pass more conversion from methanol to DME. The penetration of this technology into the industry primarily depends on two things. One is in fact, largely depends on the price of the natural gas, because most of the natural gas based, the methanol plants today are primarily from the fertilizers, whether it is GNFC, we talk of RCF, or we talk of Deepak fertilizers. They are all gas-based urea production units, wherein methanol is a side product. So the price of methanol, which we see today, which is at an import price of about 28,000 rupees, is equivalent to a gas price of something like $8 per BTU. And the break-even that we get with the price that we arrive at from domestic production of methanol with imported LNG vis-a-vis the imported methanol is just sitting at something like $8 to $9 of gas, which is right now the price of imported LNG. So if this price stays, as we see, the gas is in plenty and it's a buyer's market internationally, we do see in the industry acceptance by way of implementing projects from methanol to DME. Everything is has to be competitive. Every process, every product has to find its place on its own 2 feet. So the role, the commercialization of that technology, the key is a good catalyst, a good process, and of course the feed price and the resultant product price. And the technology that we will be scaling up from the takeoff point that it is now with respect to the experimentation and the kinetic data which is being generated will definitely bring value to that these issues that I have stated in terms of the cost effectiveness, optimized energy, and maximization of yield, such that every ton of feed results in the lowest value of product of DME. With respect to the absorption of DME, there are already tests and there are already standards, and in terms of design of stoves, in terms of specifications, in terms of notifications, which will easily find way. So the challenge now that both CSIR and EIL together have to bring out a cost competitive technology which will penetrate the market. Herein, in the complete acceptance of DME as an option in terms of fuel blending holds the key is basically looking at alternate sources of feedstock, not just LNG or gas, but also as coal. This is very important, and from the perspective of Indian coal, the high ash Indian coal that we have, which has low sulfur, has a high ash content, high reactivity. The technology for gasification, which is going to be of prime consideration in terms of arriving at the cost price of the syngas. And the projects which are looking at polygeneration, looking at multiple products, will be most important to for the decision making of the the variety of products which this the gasification of coal would need. Therefore, as we go forward and we look at a commercial plant wherein we take the TRL 6 and 7 to 8, is essentially can begin with LNG, but from the long-term perspective to find substantial end use, the impetus which is now already there, the R&D projects which are there for gasification of coal to syngas will be bridging the gap between the gasification technology, the cleanup technology, and the methanol conversion and DME. And as we go along in few years' time, because technology development is a long process, the shifting of our energy dependency from crude to coal is what is likely to happen. Although we have been seeing, this kind of dialogue for years, but as we see, and if you read, there are several projects which are being pushed in terms of evaluating technologies, looking at feasibilities in this direction. And this is likely to reduce the import bill significantly and bring value to both the investor as well as the end users in terms of price competitiveness. To complete the whole dialogue and not mention about the the aspect of renewables, any discussion, any kind of would be incomplete. So the essence of tomorrow towards net zero, towards looking at complete renewable end-to-end processes, is looking at biomass gasification and looking at that whole value chain up to making the renewable DME or bio-DME as we go forward, which is going to be the future holds, and the technology that we will NCL, the catalyst that NCL has developed and the technology which will come forth will be quite suitable to that. Of course, when we look at these renewable pathways, they need to be held together with the interventions of policy, because they would not be able to stand on their own right from the beginning. And with the thrust that we have in terms of the commitment of bioethanol, commitment to the Paris Agreement and the INDCs that India has committed to, in times to come, we anticipate that policy initiatives and also allocation in terms of support will be pushing the nation towards renewable fuels, and bio-DME would be one of them. So with this, I compliment NCL team for such a very strong and very development on the catalyst front. We do have catalyst internationally, but our own domestic developed catalyst, which is unique and which is much above the comparisons that the teams have done against any competition, is likely to lead this towards success very soon. EIL is committed to this, and I hope that next time that we have this webinar, there is on DME, there is more substantive groundwork that the teams can share. Thank you very much.
Thank you, ma'am, for your talk and also for informing us about the wonderful association of EIL with CSIR NCL in taking the developments of DME towards commercial level. So also you have given such a fantastic view on the import of crude in the country and the role and importance of an alternative fuel like DME in making the nation Atmanirbhar. So I'm sure with your wishes in the upcoming webinars, we'll have more on bio-DME as you have suggested. So looking forward, thank you once again. So let us move forward. Our next speaker in this session is Dr. S.S. Thipse, who is Deputy Director at Automotive Research Association of India, ARAI. Dr. Thipse has done his Master's in Thermal Sciences from Bradley University, USA, and his PhD from New Jersey Institute of Technology in the field of alternative fuels combustion. He has research experience of over 20 years in the development of alternative fuel engines and vehicles and has been working at ARAI since 2004. So currently he is handling the development of CNG, LPG, HCNG engines at the Power Training Engineering Laboratory at ARAI Pune. He has completed successful several alternative fuel engine and vehicle projects for major OEMs. So with this brief introduction, may I now invite Dr. S.S. Thipse for his talk. So over to you, Dr. Thipse.
Yeah, good afternoon. Thank you, Dr. Shikha. And it's a pleasure to talk at this forum on behalf of ARAI. And special thanks to Dr. Lele also and Dr. Raja and my previous speaker, Vartika ma'am. I think they have given a very good overview of the subject. I will touch upon some of the points which are left out more from the application side, but I think both the earlier speakers have made my job very easy. So I'm just sharing my slides. I hope. Okay, are they visible?
Yes, sir, but please go to the, yeah, it has come in presentation.
Okay, yeah. Okay, thank you. Yeah, so I'll talk about, I think my previous speakers have already said the background for the speech, but the primary drivers which I feel right now for any alternative fuels in India, I've just listed them here. Of course, the vision of Atmanirbhar Bharat in terms of self-reliance in terms of fuels. Also, the GHG mitigation has become very important, particularly the greenhouse gas, the global warming effects. And we have also signed the Paris COP agreement, and we really need to adhere to the goal of a low carbon mobility to ensure compliance to having the temperature rise restricted to below 2 degrees. Also, the local environment pollution plays a major role. If you see, our major cities are being referred as most polluted cities in the world. So this is one major issue of concern. And along with the, in terms of boosting the economy, in terms of kind of having fuels which will generate revenue for the country rather than spending money on importing fuels. So this is one of the major tasks at hand. And I feel DME fulfills all these criteria. So it is one of the very good fuels for the future. Just one slide on ARAI, because we are working in this area for a long time. We have done several R&D projects and we are very, involved in terms of regulation making. The CMVR standards, we are involved in various BIS committees. We are also the certification agency for vehicles and gensets. So for gensets, we certify as per CPCB norms. Vehicles, we certify as per CMVR norms. We are also incidentally involved in training and IPR and consultancy. We run out of 3 campuses and Kothur being the major campus. So going further, Government of India has released notifications for several alternate fuels. Now, in the last few years, we have seen notifications ranging from bio-CNG, ethanol, hydrogen CNG. But the most important thing to me is the first synthetic fuel notification that was for DME, which was released in January 2020, was a real landmark because we had notifications for gaseous fuels, we had notifications for biofuels, but to have a notification for a synthetic fuel in itself was a big achievement. And I must say that ARAI played a major role in terms of releasing this notification closely along with the Ministry of Road Transport. Now, if we see, I think I'll skip this slide because my previous speakers have already talked about it, but we are in the area of alternate fuels, and that too synthetic fuels play a major role now. Now the DME can be generated from multiple sources. So traditionally, it is formulated from natural gas, so natural gas synthesis. But now the method developed by NCL is to dehydrate methanol and then generate DME. So that's a very good method. And essentially, as if you see it as an engine fuel, it's ideally suited for a compression ignition engine because it has a C10 number more than 55. So really, it is one of the very good fuels. I'll give some data, international data also, and what ARAI has done in this. So if we see the property wise, it is having excellent properties and more like a vapor. So it is like vapor at room pressure. And then when you pressurize it, it becomes something like a liquid. So the characteristics are similar to LPG, and hence you can store it very easily in a LPG cylinder. And these are some of the characteristics which make DME very simple to handle. So it is an ideal CI engine fuel, but the characteristics of handling are similar to LPG. Then again, as I mentioned, DME can be produced from multiple methods, but I think dehydration of methanol is a good area where we can work. Then DME worldwide, who has done what? So we found that there are certain studies already conducted worldwide on DME, particularly in countries like Sweden, where Volvo was very much essentially involved in using DME as a truck fuel. USA also did some basic work on DME with government labs, and Germany, the Aachen University and others have also partnered. Denso has supplied the fuel injection equipment. AVL also, Austria, they have worked on the DME fuel and they have developed a DME common rail. As far as India is concerned, DME was again initially started off way back in '98 with IOCL, GAIL and IIP. But then later on, not much progress was done. And eventually ARAI and NCL got together and we demonstrated the first three-wheeler on DME LPG blend. Then Japan, 2 DME trucks are running with the technical regulations. A lot of activity on DME in Japan. They have several standards and they are contributing to ISO standards also. If we see the worldwide applications, this is a multi-purpose fuel. There are multiple applications. It's not just restricted to automotive, but it's useful for power generation. Again, Dr. Raja showed many of the different applications. So it's a precursor to fuel additives. It can be ideal replacement for diesel, then again, replacement for LPG and so on and so forth. So this on the right side is a truck based on DME, which is running in Sweden. So these are some of the engines which are already developed worldwide. Volvo truck is there, then Scania also some engine is there. Then there is a SAIC engine in China, then a Mack engine, which is also running on DME. Typically, these are 6-cylinder, 8-cylinder engines suitable for truck applications. Now, why the truck application is because they, in terms of the characteristics, it's similar to diesel. So the torque and power characteristics are good. Although the calorific value is less, that can be compensated by having different turbocharging techniques, and you can have special applications and increasing manifold volumes and different ways in which you can try to recover the power loss due to lower calorific value. Now, as coming back to the standards and regulations, India has already adopted the ISO standard for the DME. So this particular standard is the fuel standard, which has been dual marked by our Bureau of Indian Standards. And that standard is already adopted. That is ISO 16861 for the fuel quality. So we already have a DME fuel quality standard in place. The second point is in terms of the notification, which I already mentioned to you, that GSR 37 has been released and DME as a fuel for both below 3.5 ton and above 3.5 ton, as well as for three-wheeler vehicles. The norms have already been released. What are the tests applicable are also been specified. Then this is the reference fuel, as I was talking about, the ISO 16861, which India has adopted with a purity level of 98.5% and all the remaining parameters as explained below. Then the components. Now, just having a fuel standard is not enough. We also need the component standards. Now, by component, I'm talking about the fuel systems, the injectors, the valves, and the pressure relief devices. So again, we are adopting the ISO 22760 series. There is a committee, BIS TD 26, chaired by ARAI. I am the chairman of that committee. In that committee, we are discussing and adopting various fuel system components. So we have CNG, we have the ISO 15500 series, LPG component series. Similarly, we have the DME series now. So in that, the different almost 18 to 19 component standards are there. Now, some of the at least 6 parts are now already developed and they are in wide circulation. So this committee is going to finalize all the component standards, which will ensure that there is a safety net for the Indian manufacturers. They can conform to this standard, which are at par with the ISO levels, and then they can supply these systems in India. We are also developing the AIS safety standard for DME LPG. So that LPG, the safety standard is already available, but the same standard we are now adopting and extending it to DME and DME LPG blend. Only thing is the gas cylinder rules need to be amended for DME. So we have initiated dialogue with PESO for inclusion of DME as a fuel, because already Ministry of Road Transport has notified it. And so we are hoping PESO would allow DME storage in LPG cylinders. So those discussions are already in place. And then OISD standard for dispenser has to be developed. This is something which is missing. So that also we have taken up with the ministry for development. Then coming to the use of DME in the CI engines, essentially one of the unique characteristic of DME is it has a low boiling temperature. So low boiling point and high vapor pressure means you need to have some changes. So that fuel supply has to be pressurized. You can't give it at room pressure. So you need to have some kind of pressurized fuel supply. And you also need to ensure that there is proper sealing done to avoid any leakage. And we also have to modify the plunger diameter and nozzle, because we need to now, as I said, have more fuel to get the same amount of energy because of the lower calorific value fuel. And also in terms of injection optimization is also required. Further, we need storage tanks. Again, that's a slightly large capacity tanks to have the same amount of fuel to get the same range as diesel. So this storage pressure is typically similar to LPG, as I mentioned, 8 to 10 bar, typically average 9 bar. And all of this can be done very easily in the field. So you can put the DME tanks, you can make the changes with a minimal changes in the engine. So retrofitment of DME is very, very simple as far as the vehicle is concerned. It is not a very big job like CNG, where you have to change the entire engine configuration from compression ignition to spark ignition and then adopt the CNG kit. Here, nothing like that is required. It's a very, very simple adoption. And again, there are a lot of advantages too in terms of clean combustion. I'll share some data also. A totally non-toxic and low global warming potential, easy to store. So there are many advantages for DME, which is ideal from an auto perspective. But there are some challenges also, as I mentioned to you, the calorific value, the high vapor pressure. That means that the system has to be pressurized. We really need to worry about the gasket and seal material compatibility. So that kind of data exercise ARAI has already started in terms of following the different ASTM protocols and studying the metals, non-metals. We did similar work for methanol, we did similar work for ethanol, and now we are in the process of doing this for DME. And again, combustion also is another area where a lot of work is being done in some IITs also. DME is ideal, as I said, clean diesel alternative. There are a lot of reference data available worldwide where people have done DME and they found that It has excellent characteristics. Like this is a data from Isuzu and Volvo, and they found that it is meeting the best of the emission norms. So it's a winning combination. And this is a data from AVL, which shows that the DME engine is far cleaner than the diesel. Almost no smoke observed in the combustion, 90% NOx reduction, and it meets all kinds of standards. So this is data from AVL. Again, other applications, DME and LPG interchangeability. One can look in terms of developing DME as a fuel for replacing LPG also, or it can be used along with LPG also. Both possibilities are there, and both can be considered here. So, okay, I'm sorry, I think I went ahead. So pardon that. Yeah. Then coming next is DME plus LPG for cooking. Dr. Raja already mentioned that this is also a topic of great interest for India, and there DME plus LPG can be a very good source to supplement and make up for the deficit of LPG, especially with the Ujjwala Yojana being produced. And I think that's a very good initiative. Again, in terms of DME LPG, research was carried out earlier by LERC also. They tried to do a lot of work on burners, and they did some excellent work, which was the path-breaking work, and then later on carried out by NCL. So a lot of conclusions, and there also ARAI was slightly associated with the LERC that time. Then NCL again, he showed, Dr. Raja showed the planned inauguration by the minister, and also the inauguration of the unit. And we were very happy to associate with this whole program. And this is the vehicle which Dr. Raja showed. This was from TVS Motors. With their kind permission and assistance, we were able to source the vehicle, and we were able to undertake trials at ARAI on the three-wheeler chassis dyno with all kinds of instrumentation. And we evaluated various blends of DME LPG, particularly 30-70, 50-50, then 20-80, and kind of generated data on different blends. And we found that the exhaust oxygen levels increased by around 17%, and there was benefit in CO emissions observed with a slight increase in HC NOx, but that can be taken care by tuning. We are still doing that. We are now awaiting the final configuration. And also for the catalyst, we have not done any modifications, but with the modified catalyst, I'm sure the performance will further improve. So as far as I'm concerned, driving forces for DME in India is it's a well-researched and tested fuel over last 10 to 15 years in several countries. So it is one of the tried and tested technology, easy to blend with LPG, established technology available, and environment friendly. So you have something which has worked outside, which is environment friendly. It can be easily made, and thanks to the path-breaking efforts of NCL, now DME is very much a reality. I remember a situation 8 to 10 years ago where we had tried in ARAI to initiate a project on DME, and we were told it's too early, and unfortunately we were not able to source DME that time. We even asked the Indian Oil, and unfortunately nobody was able to provide us the fuel at that time. But now I am happy to say that we at ARAI have initiated 2 or 3 technology development projects, and we will also look on DME as for heavy duty applications. And I am very happy to note that we have signed a MOU with NCL, and we'll be very closely working with NCL for taking this DME program further in India. But there are some concerns in terms of material compatibility, and again, awareness among people is very much lacking. So I think we need seminars like this, particularly reaching all kinds of regulatory authorities, and also in terms of users, end users, kind of educating them what is the benefit of using this fuel, how this could help the Indian conditions, and how this fuel is suitable for India. And again, the fueling stations and then infrastructure and all that thing is required. But definitely one can say that it is a fuel which has a huge potential, especially if you talk about trucking sector, where CNG cannot be used, or even they are still running on diesel in many of the remote areas of the country. I think DME can be a very good fuel for that kind of considerations. So there is a lot of potential for DME. That's all from my side. And thank you again for having me here. and I'll be happy to answer any questions which anybody has. Thank you very much.
Thank you so much, Dr. Thipse, for such an informative talk. So, giving us an overview on the international and national positions of DME and its applications in transportation arena, basically. Also, the stages and regulation for the development of DME fuel systems and its components. So, it's very good to know about the collaboration between ARAI and NCL for commercial applications of DME. So, my best wishes for the further development on DME. So thank you again, all the speakers, for your informative talks and sharing information on the DME technology. We have a few questions from the viewers that I would like to take up to all our participants here. Dr. Thipse, if you can stop sharing the screen, so we'll be able to see our other participants. Yes, sir. Thank you. So, yeah, people want to know about the difference between ethanol and hydrogen, why DME is better as compared to ethanol and hydrogen as a fuel. So, Dr. Raja, if you can explain in a brief.
Yeah, ethanol is isomer of DME, but it has advantages for the boiling point and everything, cold start, and then less soot. When ethanol is, we have to blend with kind of gasoline and everything, with 15%, 20% everything. Whereas in the diesel trucks and everything, as Dr. ARAI, Dr. Thipse told, with 100% we can go. So it's a very good advantage over ethanol with the DME. But hydrogen, actually, Dr. My director asked Srile can tell for hydrogen over the DME.
Sure. So hydrogen is emerging as, there's a lot of interest across the world in hydrogen-based transportation. An interesting alternative for heavy commercial vehicles. But this is a little bit in the future. The advantage of hydrogen, of course, is that you can make it from sunlight and water. So it's as clean as it can get. However, the economics of it has to work out. In terms of its energy density, it's one of the highest energy density fuels. So it's ideally suited for heavy duty vehicles. Only emissions are water vapor, so very, very clean. So it is really, the fuel of the future. But we have to wait until the economics works out for replacing diesel with hydrogen. And in that meantime, I think DME would be a very wonderful fuel. As Dr. Shukla also mentioned, it's a great fuel for that transition. And especially if Indian coal can be valorized through DME, that would be wonderful, absolutely essential for India. And again, a little bit futuristic. I know we are all scientists, so we like to think about the future. We like to know about what is there. Sometimes the economics doesn't favor it right now, but eventually it will. If you can, as I said in my earlier remarks, if you can actually extract CO2 from the atmosphere, and there are wonderful technologies today in place where CO2 can be extracted. The prices today are about $100 a ton of CO2, but they are expected to come down to as low as $30 a ton of CO2 by carbon capture, even from air. So you can actually remove CO2 from air. And that CO2 to methanol to DME is a very organic connection, right? And that would be an absolute wonderful way of decarbonizing transport industry. So jury is not out yet whether DME or hydrogen or what clean fuels will make it, but I think it's absolutely understood that we have to move to cleaner fuels. We have to move to self-reliance in terms of fuels, especially for India. So we will wait and see what happens. And from NCL point of view, we have very deep interest, both in DME and in hydrogen. So we'll be involved in the clean fuel transition in India, very much so.
Thank you so much, sir. So next question is from Devendra Shakre. He wants to know whether NCL has developed the catalyst and technique for DME production from syngas. At what level and what is the yield of DME per cubic meter of syngas?
So at present we are concentrating only dehydration, methanol dehydration to DME. Then syngas and everything, as Dr. Lele told that, Dr. Ashish told that, the valorization of coal and everything we need to do. Syngas and everything so far we have small work. We have done at 2007 we initiated syngas to directly DME, but it's a laboratory scale level. Yeah.
So yeah, next question is from Dr. Matthew Abraham. So how far the conversion of Indian coal with high ash content would be economical for methanol and DME conversion? So this can be addressed. How far the conversion of Indian coal with high ash content would be economical for methanol and DME conversion?
You want me to take the question?
Yeah, ma'am, please.
Okay, thank you. So gasification has always been a technology looked up for, you meeting domestic need for fuel, and has always been very challenging in terms of both technology as well as the extent of investments which are required to make an economy of scale. In particular, when we look at Indian coal, it is plenty, but it has very high ash. Technology for high ash coal conversion to syngas is still in the process of development, and EIL is also involved with Thermax in development of that technology. It's a challenge, particularly because the balance between the exotherms and the endotherms in terms of the kinetics. The heat balances are challenging, and I'm talking of fluidized bed where we are operating above the ash fusion temperatures, and therefore the experimentations are still underway, and probably a higher capacity plant would be required to kind of get rid of the effect of heat loss from a smaller equipment and get to more understanding more of the chemistry and the physics of it. Insofar as the commercial application of technology goes in terms of high ash, up to about 25% ash, the technologies are there and they are being deployed. The technology is more intensive in terms of energy and air requirement, particularly because it's entrained bed. So the ash in coal is actually slagged. So it is a very high temperature and very fine particles of coal are there. It is energy intensive. So that's the stage. So if we were to look at a technology today to completely set up the end-to-end chain from coal up to poly generation, including methanol, it would be with technology which is proven, which is something like 25% ash coal. In combination to that, if we have a very high ash coal of 50% or so, 45-50%, then we need to see the economics of a washery up front before we actually put this coal into the gasifier. So that's how it stands today. And of course, there have also been dialogues wherein extensive work has been done to map the coal fields by CMPDI, been discussed with Niti Aayog, whether we can allocate a certain kind of coal for gasification. So it's like distribution of coal types as China has done in terms of policy, that the high ash goes to the TPS, which are designed for high ash, and a medium ash coal goes for chemical end use in terms of clean coal technologies. Thank you.
Thank you, ma'am. So another question is use of DME apart from fuel. Is there any other use of DME? I think it is an alternative to the fuel itself.
Yeah, DME can be used as a chemical commodity also. So even NCL has a patent on how to use DME as a chemical commodity.
Okay. So one more question has come. Which one is cheaper between renewable DME and synthetic DME?
Renewable DME always not cost effective. So degradation is effective now, as on today.
Okay, so I think we are done with the questions from our audience. We are nearing the end of this session. So thank you all the speakers once again for the talk and sharing information on DME technology. It was great listening to all the panelists today and was really fascinating to know about the process of DME and its uses as an alternative fuel, which will greatly impact our society definitely. So may I now invite Director NCL, Dr. Lele, for delivering the closing remarks for the session. So over to you, Dr. Lele.
Thank you, Shikha. And first of all, let me thank Dr. Shukla and Dr. Tipse for taking time out of their very busy schedules and participating in this very wonderful webinar. I wish we had our engineering students listen to seminars like this, because they get a complete end-to-end picture, which they cannot get in any YouTube videos or any textbooks for sure. Dr. Shukla, for example, started with laying such a wonderful context in terms of why DME is important from a national perspective, from self-reliance perspective, the economics of it, and how from primary sources like coal, we end up with synthetic fuels like DME. And then Dr. Tipse talked about the other extreme, which is once you have these fuels, where do you use them for? Why are they important? How do they place in the energy mix or the fuel mix that is available today? So many options are available today. What is the place of DME in that? So such a wonderful amount of information end to end has come out of this series. And what can I say about Dr. Raja? Such passion in developing technology, in translating science, is very rare to see that kind of passion. And we are very proud to be part of NCL, which cherishes both science and technology. We firmly believe that there is no good technology if there is no good science. And we also believe equally that just doing science in the lab is not enough. For a lab like NCL, translation, walking down the road of science to technology is equally or perhaps even more important to us. And so we cherish and respect our partners because we know that we cannot achieve that without our partners. So I just want to place on record, Madam Dr. Shukla, that we are with you all the time, and we want to take this technology forward. Dr. Raja has my full support as long as I'm here, and we will do everything possible to walk the mile, the last mile. And Dr. Tipse, again, we are with you all the time, and whatever help you need, we will surely be there. So do count on us. So thank you very much. Thank you, Shikha, for this wonderful coordination. And I must thank also CSIR for this great initiative of celebrating science and celebrating technology through this series of webinars. Thank you so much.
Thank you, sir. And very correctly said that this information should reach our young minds. So we are targeting that only, and we are conducting this kind of webinars so that our technologists from CSIR and our association with various companies and collaborations should be highlighted, and it should reach the people. They should get to know what is happening. So thank you very much, all of you, and really a great thank to our Director General CSIR, Dr. Shekhar Mande, so who has been always the driving force behind the whole activity of science communication. The entire team at NCL, and thank you, Dr. Ashish Lele, for helping us in formulating the session and also for joining with us today. Our participants, Ms. Vartika Shukla, Dr. S.S. Tipse, Dr. Raja, and the full team, definitely from NCL. And also the team at CSIR headquarters, Dr. Mitawani, Head Science Communication Directorate, and Dr. G. Mahesh, Mr. Deepak Jain, and the entire team for making this session a success. So finally, a special thanks to our viewers for joining with us and interacting with the speakers. So as I mentioned in the beginning, this is a part of series from 80 years, 80 success stories of CSIR and Azadi Ka Amrit Mahotsav. So we have planned this to happen every week on a particular success story of CSIR. So our next upcoming story will be on CSM ARAI Bhavnagar. So please stay tuned with our upcoming sessions on the successful stories of CSIR. Bidding you goodbye for now. Namaskar.
Thank you.